Alright, so I'm just looking at question 6. It's this boy holding a kite. Now, the tension in the kite string is 400 newtons. That's the tension, not the length. And the boy's weight is 600 newtons. So the weight is the force acting straight down, gravity, etc. Calculate the magnitude of the resultant force on the boy. Now, this question can stuff people up a little bit, because they see the boy, they see the arrow going straight down from the boy. But remember, you've got one vector going this way from the boy, one vector going this way from the boy. But if you're going to find a resultant force, you've got to add those vectors together. And to add those vectors, you've got to do tip to tail. So take the force from the boy, move it up to the tip, and the question actually becomes something more like that. 400 newtons in this direction, 600 newtons in this direction. So what you eventually end up with is a force acting on the boy in that direction. The kite's pushing him forward, but the force of gravity is still pushing him down into the ground. So you end up with a force heading in that direction, but down into the ground a little bit. So now that we know what the drawing looks like, the question becomes very, very straightforward. Now, question 6. So, 400 newtons in this direction, 600 newtons straight down, and we have our boy, so this is going to be our resultant force, which I'll just call U plus V, because this is U and this is V. So there's our resultant force, this dotted line here. Now, the angle between the ground and the kite was 28 degrees, you can see there. So I'm just going to do a little bit of work here, because I've got a right angle triangle, so I can probably use the, I've got a triangle, so I can probably use the cosine rule in some way, but that angle's not going to help. But if I use my Z rule, I can say that that's 28 degrees there. And if I can say that that's 28 degrees, and that force is acting straight down, then this is going to be 90 minus 28, which is going to be something like 62 degrees. Alright, so now I have a pretty standard triangle, 400, 600, an angle between those two of 62 degrees, and I should be able to find the magnitude of the resultant force. So again, it's the cosine rule. U plus V squared is going to be equal to 400 squared plus 600 squared minus 2 400 600 cosine 62. Type that all into your calculator and you should have an answer. I'll speed this up, put it all over that one. So U plus V square root the whole lot. Alright, that gives me an answer of 542.82 newtons. Now you might want to think about how you could solve this question using components, because you can solve it using components. So if I find the I component, so how the I direction here, and I find the J component of that vector, and then I know that the I component of that vector is just 600, then I can add those vectors together and then use Pythagoras to find it. If you're interested in that, come and talk to me and I can talk to you one-on-one on how you would do that. But yeah, for this question, cosine rule worked just fine.